So today we're going to start working with Animate vector nodes, which is basically kind of be thought of an animation nodes version of keyframes, but it's a lot more powerful. And I also want to show, hopefully stimulate some sort of imagination ideas of what's possible with animation nodes and finding and using vertices from other sources other than just typing them into a node. And that'll make sense in a little bit. So the very first thing we got to do is we need to create our cube. Now you've done this before, so I'm going to speed line it. So we want to make it 7.4 seems to be a good size. And what I want to do is I'm going to subdivide this until we get 386 vertices. Now basically what we're going to do is we're going to take the location of each one of these vertices, and I want to say, hey, put a meta ball there. And then what we're going to do is we're going to find a new location of vertices on this ball that I'm about to make and say go there. And then we can manipulate that transition to create a really cool effect. So the first thing is first, I need to turn this into a sphere. So we're going to look for a 2 sphere, and then we just turn this guy all the way up to 1. Now we've got a sphere and a cube. And this can work for any shape, but the important thing is that each shape needs to have the same amount of vertices. Otherwise, some objects will be left behind, or there'll be holes in the other object if they have too much or too little vertices. So as long as you have 2 meshes with the same amount of vertices, you can do this effect. So now what we need to do is we need to create our meta ball. And since we're going to be dealing with 386 meta balls, I'm going to half the resolution here, so it doesn't tax my system too much. All right, let's get started. So first things first, we need to get all these vertice locations. So what we're going to do is we're going to go to mesh and mesh input. And basically if we give them, this node means if we give it a mesh, it's going to give us some data from that mesh. So we're going to eyedrop our cube, and suddenly now we have all the vertex locations and all the locations of the center of all these polygons. Now what we want to do is we want to place a meta ball on each individual vertex. And there's 386 vertices, so that means we need 386 meta balls. So we're going to use the object instancer. We're going to use the meta ball as our instance, and we're going to take the amount of vertexes or vertices in the vertex locations list as the number of instances. So you can just drag and connect that, and I'll add a get length node in the middle. So now what happened is, we haven't seen this yet, but what's going to happen is I didn't click copy full object. So our instances here have a random name. And for the meta ball system work, just for legacy issues, we're going to call this Greg. For meta ball instances in Blender, they all need to be labeled Greg and then an appendix, Greg dot whatever. So we're going to click copy full object. So now we have a bunch of Gregs, and now the Gregs exist in the world. All right, so now we need to tell every single Greg to go to a vertex location here. And what we're going to do is we're going to set up our loop tree right away. Because otherwise we can have a little bit of issues. So we're going to go ahead and click loop through objects. And then what we need is we also have now we're going to have 2 lists of vertices to work with. So we need to add these vector lists to our loop program. So we're going to have these vectors from where we start, and then these vectors from where we finish. So we're going to go ahead down here and we're going to create a new vector list. We'll call that start. And a new vector list, we'll call that finish. So the start is going to be from this mesh. I couldn't grab it there. From this mesh. And the finish is going to be from my other cube here. We'll call this square cube. And we'll call this round cube. Or we'll just call it sphere. There we go. So now what we're going to do is we'll go ahead and get things going really quick. So we'll do object transforms output. We'll bring our meta ball will be the object of which we want to transform. And then the location of our start, we'll start off with putting them there to begin with. So we've got our meta balls all on my cube. And what we want to do is we want to tell them to go to this location, but we're also going to make it look really sexy and cool along the way. So first thing is first, we're going to whip out we're going to whip out an animate vector node. And this is kind of like animation node's version of keyframes, where if I get 2 vectors, it'll go from there and I can tell it how long to do that and in what kind of interpolation to do that. So what we're going to do is we're going to plug in the vertex location on this cube as the start, And we're not going to go straight to this cube. We want to have a nice, cool transition. So the first thing to do, just to visualize this, is I'm going to explode these. So what I'm going to do is I'm going to go to vector math. And what we're going to do is we're going to multiply the locations of our guys, multiply by 2. And what that's going to do, I shouldn't have put it there. I wanted to put that in the end part. Put the start here. There we go. So what I want is that we're going to take whatever the location is of our metaballs, and then as we scrub through the timeline, I want them to explode twice. So if you imagine the X, Y, and Z coordinate of this vertex or this location of this metaball right here, the X, Y, and Z location is going to be multiplied by 2. So as we scrub through this, let's put an egg on my face now. Why is this doing put an egg on my face right now? Oh, I didn't plug this in. That's why. There we go. Now, as we scrub through this, we can see that the radius of our cube doubles, or the volume quadruples. So now what we're going to do is we're going to go from this new location to this location. So we can just see what's happening. And then from there, we'll start to spice things up and make it look more interesting. So in order to do that, we're going to go ahead and duplicate our animate vector node. We're going to use the result as the start, and then we're going to use our finish as the end. And then we're going to plug that up. And now what we can do is we can plug the timeline into the time. And now as we scrub through the time of the first one, it also scrubs through the time of the second one. So now we've got this cool effect where it goes. So there we go. We're about 20% of the way. The real difficulty is creating the really cool, interesting effects as we do this. So first thing is first is that I want to not have to drag the time value to do this. So I'm going to go ahead and go to animation, time info, and I'm going to plug in a frame info to do that for me. So now when I press space, it'll do it for me ever so slowly. I'm going to go ahead and bump this up to 0.1, make my computer a little bit happier. All right, so you might have noticed that I typed 0.1, I meant to type 1, so my computer really slowed down there, and I just cut that section out. So yeah, it goes from 0.8 to 1, not 0.8 to 0.1. So now when I press space, let's go ahead and open up a timeline down here. It should with a little bit higher FPS transition over. So now we're going to try to spice things up. So first thing is first, it looks too robotic. So what I want to do is I'm going to go ahead and add some easing in. So we'll do sinusoidal, and we'll add some easing, ease in, ease out, ease in, ease out. There we go. So now it'll come out and it'll go straight into that guy. And then we have a little bit smoother of a transition. And what's really powerful about animate vector nodes is that I can actually start this vector animation while this one is occurring, and they'll morph together. So if I go into number and math, if I plug this in here, I can subtract. I'm sorry, we want to add in this scenario, add. So we're going to add a little bit. Because what happens is when this duration is ending, that's when this time equals 0. So we'll do a viewer here of time. So once, as you can see here, it starts off as minus 20. And then once it gets to 20, it starts over at 0, at which point this guy would take over if it plugged directly into the time. But if I want to add some onto there, instead of being 3, I can add, so let's go here. So instead of being minus 5, I can add 5 here. Just type in 5. So now it's going to start moving before this one even finishes, because we're at frame 15. This one doesn't finish at 20. So now we can start this one without even finishing that one. So we can get, the more we add to this, the more we can get a morph here. So now it's going to be a little bit more of a morph versus the explosion. And if I set this to 20, I'll start them at the same time, and you'll get an explosion and a morph too, like that. So that's where the animate vector nodes are very powerful, as you can do 2 at the same time, and you can morph two motions together. So now what we're going to do is I want to create a little bit, so we'll bring this down a little bit so we have more of an explosion. What I want to do is I want to add some noise. So instead of just being a box, I'm going to go ahead and click vector random, and then I'm going to set my index of my list to the seed And then I want to add that to my vector math. So we do vector, or not my vector math, well, that's math node. So add these together and put that to the end result. So now we've got a little bit of a mess going on here. So it looks not so robotic. So there we go. Now we've got a nice, cool little transition. We're sort of almost there. So now what we have to do is, we look at the end result that we're going to look for, is that I want to create it so that it comes out, it squishes down, and then it gets a little bit bigger. Now, the hardest part about achieving effects like this is you need to think about how could you do that. Now, I could tie it to the X location. So as the X location increases, I want the Y and the Z location to decrease. So we can see that here. So if I make these 1, it'll shrink. I can make this 0.2 to make it even more obvious. So if I had the X location increase, I could shrink the Y and Z location. The problem with that is you create, I don't know if it's like a paradox, but it doesn't work in the loop because we're using location to dictate location. So that's sort of a paradox. So what we can do though, is we can simply tie it to the frame. So as things move, they get smaller. And then things further to the right move a little bit quicker get smaller quicker than the ones to the left. So how does that work? So what we're going to do is we're going to create a vector combine. And basically we're going to set 1, and then we want our time info to dictate the shrinking of this. So we'll take map range, and we'll plug this guy in for now. So now it's going to go from 0 up to, let's say 20, sure, the usual duration. And I want it to start out at 1, and I want it to shrink down to like 0.2. And then we can plug this directly in. So if we start off at frame, well, it's going to start off at frame 1, but it's going to start off at a frame, and then as this frame increases, it's going to go from 0 to 20, or it's going to go from 1 to 0.2. So the Y and the Z values are going to shrink, and so as it moves, they'll shrink down like that. But the problem is they're all shrinking at the exact same time. So what we need to do is we need to say, hey, I want the X value to dictate how soon they shrink. So what we're going to do is do number, math, pop that in, we're going to do add, and then we need to dictate the X value. Where are we? Vector separate. So we're going to take the original location, and we're going to take the X value, and we're going to add that in. X value. There. So now you can already sort of see how it's shrinking, but now the X value will dictate the shrink. So you can see it shrinks like that, and then it gets taken over by our second animate node before it can really shrink, but you get this effect. That's shrinking, and it's getting globbed onto that guy. So what we're going to go ahead and do now is we just got to do the inverse on the other side. So it shrinks, and then it gets big. So now we need to go from, it gets big, and then it shrinks. Now you have to do shrinks, and it gets big. So what I'm going to do is I'm going to bring this back down to 0 so we get a little bit more of a nice... So anyways, sorry, it's really easy to get distracted while playing with this. So now what we're going to do is we're going to do the exact same thing, but the inverse with the end. So I'm going to go ahead and create my map range. And I'm going to take the value, so we do the end. It gets here at, well, I kind of want to make this a little bit longer, so we'll do 30 and 30. So it goes over here. So it winds up here at like value 53. So we're going to go ahead and put the max as, I don't know, 55, and the input at like 40. So when the frame is below 40, it's not going to touch it. And then once it starts getting above 40, it's going to start modifying it. That's what this little range here. So from 40 to 55 is when things happen. Anything below 40, we'll leave it at the value of 0.2, dictated by this map range over here, see 0.2. Anything above 40 above 55 will become 1. So now what we do is we simply take our math result and we plug it in to the value. So we just inversed it basically. And then we can take this value and we plug, we need to do another vector math. And then we need to multiply. by another vector. And then we bring this guy into the Y and the Z. And then now it comes up like that. So we have a shrinking motion and a globular motion. So now right now it doesn't look quite like what we want, so we can modify that. So the first thing is first is we can see, okay, it takes too long to explode. I want to explode a little bit sooner, so I can bring my input value down. So we'll bring this down to like here. And then there we go. We need this to be a little bit faster, so we'll bring this up. So we'll have it take like that. Oh, it's so fun. Actually, I want this to take a little bit like that. There we go. It looks a little bit better. And then we'll go ahead and instead of making it linear, we'll make it happen a little bit faster. So we'll make it quadratic. So it should be a little bit more of it. There we go. That looks cool. All right, so the last thing we need to do is I don't like how it shrinks and then it goes. And I also don't want to have to rely on this part because I could morph it some more. I could morph it so it goes like that, but it just doesn't look right. So what I'm just going to do is undo that. Instead, I'm just going to have my end result, this guy, I'm just going to move him over. So I'm going to say wherever you are, the end result, oh my God, it's getting messy. I want you to move over to the X a little bit more. So now the end result should look like that. Beautiful. And we can move further over. There we go. And that's, now we get the screencast keys back. But that's how you do, I don't know, that's the power of animation nodes. You can use this crazy setup here and tell it to shrink and then unshrink into this little cube. And then we can, of course, hide our cubes. And now you get this strange looking effect